Oh, hello, Y11. Welcome to your homework feedback session. We are starting chemistry, page 100 to 105. Same rule as always. Please get your green pen. Please give yourself a check if you got it right. Please write down the correct answer if you got it wrong. Let's begin. Let's do it in less than 15 minutes. Okay, first question, little warm up. The radius of an atom is approximately 0.1 nanometer. Okay, so 10 to the power of minus 10 meter. The radius of the nucleus is around 10 to the power of minus 14 meters. It's really small. It's about 1/10,000th of the radius of an atom. And an atom doesn't have an overall charge, as it has equal number of protons, which are positively charged, and electrons, which are negatively charged. Figure 1 shows the structure of a helium atom. Name the region where most of the mass is concentrated. It's in the nucleus, part A. And the electrons turning around have a very, very, very small mass compared to proton and neutrons. So most of the mass is in the nucleus. The particle B is an electron. Therefore, it is negatively charged. And you need to know that. The charge of an electron is -1. And in region A, we have the protons, which are positive, and the neutron with a relative charge of 0. They're neutral. A potassium atom can be represented by the nuclear symbol K1939. The mass number is always the big number. It's the number of proton and the number of neutron together. So in that case, it's 39. And the atomic number, which represents the number of proton, is 19, the small number, always. How many protons, neutrons, and electrons does an atom of K1913 have? So because the atomic number is 19, we have 19 protons. Because you have 19 protons, which are positively charged, we also have 19 electrons, which are negatively charged, because the charges need to cancel each other out. And to calculate the number of neutrons, you're going to do the mass number minus the atomic number. And 39 minus 19 is 20. Chlorine 35 and chlorine 37 are naturally occurring isotopes of chlorine. Which of the following statements about the elements is true? So atoms of an element can contain different number of protons. That's definitely wrong. Okay, the number of protons give its identity to an atom. Chlorine is one of 200 different elements. That is incorrect because there is a lot less than 200. There's about 120, 116 different elements. So it's wrong. Elements contain more than one type of atom. Absolutely not. Contain only one type of atom. It's compounds that contain more than one type of atom. And atoms are the smallest part of an element that can exist is true. So the last answer was correct. Why are these two isotopes of each other? Because they have the same number of protons, but they have different number of neutrons, 18 and 20. Okay, that's the definition of isotopes. Atoms of the same element with the same number of protons, but different number of neutrons. So same atomic number, different mass number. Okay, for the following question, you had for each isotope of sulfur, give me the number of proton, number of neutron, and number of electron. So the column number 1, or column number 2, and column number 4 have the same value because all sulfur have the same number of protons, 16. So what's going to change is the number of neutrons. So you're going to do 32 minus 16 for the first one and find 16 neutrons. For sulfur, 33 is going to be 33 minus 16, which is 17. Etc., etc. And you should find these values. To calculate the relative atomic mass, so this average mass of an atom of sulfur, you're going to multiply the mass of the isotope by its relative abundance and divide by 100 as such. And we want the answer to one decimal place, so the answer is 32.1. Okay, it's very close to the isotope of sulfur 32 because it's the most abundant with about 95%. Question 2.3, X has a mass number of 51 and an atomic number of 23. Y, mass number of 51, atomic number of 22. Z, mass number of 52, atomic number of 23. Which one are isotopes? So to be isotopes, they need to have the same number of proton, so the same atomic number, and different mass number. So it has to be X and Z. Okay, I calculated the number of proton and neutron for each atom on the right-hand side there. So X and Z are isotopes because they have the same number of protons, but different number of neutrons. Ammonia is a compound with a formula NH3. Why is ammonia classified as a compound? So remember the definition of a compound, it contains two or more elements chemically combined. So the second answer was correct. Okay, the first one contains only one type of atom would be classified as an element. It can be broken down into elements using chemical methods that are also valid for a compound. But the correct answer was number 2. How many atoms are there in a single molecule of ammonia? So if we look at ammonia NH3, it's made of one atom of nitrogen and 3 atoms of hydrogen, so in total 4 atoms. The following list contains a variety of substances identified by their chemical formula. Name substance B. So substance B made of, it's an ionic compound made of sodium and chlorine. So the name is sodium chloride. One substance from the list that is a compound. So you can choose any substances made of more than one type of, or more than one element. So NaCl, C2H4, and H2O are both compounds. They're made of 2 or more elements chemically bonded. How many atoms are there in a molecule of substance C? So C2H4 is made of 2 carbon and 4 hydrogen. So in total, that is 6 atoms. And C and F were reacted to form C2H6. Using the formulas of the substances, state if a new compound has been made and explain your answer. A new compound has been formed because C2H6 contained 2 carbon and 6 hydrogen. Okay, so the 2 hydrogen from F have been added to C. Next question, chemical equation. The chemical word equation for a reaction is shown below. Magnesium plus hydrochloric acid, those are the reactant, react to make magnesium chloride and hydrogen the product. Which is true or false? Hydrogen is a product in the reaction. That is true, it's on the right-hand side. The equation shows the reaction between chlorine and hydrogen. Incorrect, it shows the reaction between magnesium and hydrochloric acid, so that's false. Hydrochloric acid is a reactant, is true, it's on the left-hand side of the equation. And the equation shows the reaction between magnesium and hydrochloric acid. That is also true. So true, false, true, true. Sodium reacts vigorously with chlorine gas to form sodium chloride only. Write a word equation for this reaction. So just the words, no need for formula. So right now, so sodium plus chlorine goes to sodium chloride. And then which of the following equations correctly represent this reaction? When you write down the equation, it has to be balanced. You need the same number of atoms on both sides of the equation. And you need to follow the formula of your reactant and product. So chlorine must exist as Cl2, and we must have NaCl at the end. And Na just exists as Na. So the last one is correct. 2Na plus Cl2 goes to 2NaCl. Then, first stage in the manufacture of nitric acid is to oxidize ammonia NH3 to nitrogen oxide NO. Balance the equation for the reaction. So you're going to start by balancing the hydrogen. Okay, you have 3 on the left, only 2 on the right. So you need a factor 2 on the left. So 2NH3 goes to 3H2O to give you 6 hydrogen. Then you are going to balance the nitrogen. So you had 2 on the left-hand side because of the 2NH3. So you need 2NO as well. And finally, you're going to balance your oxygen. And if you do that, you end up with 2NH3 react with 2.502 to make 2NO plus 3H2O. You want your number to be whole numbers. So you're going to multiply each by a factor of 2. And you end up with 4NH3 plus 5O2 goes to 4NO plus 6H2O. And this is how you balance it. So hydrogen first, then nitrogen, then oxygen, then multiply by 2. The reaction below shows the final stage in the manufacture of nitric acid, so formation of HNO3. The equation is not balanced correctly. Explain how you can tell. So if you look on the left-hand side, there are 4 plus 2, 6, 7 oxygen, and there are only 6 oxygen on the right-hand side. Okay, so I got it wrong in this answer. There are 7 atoms of oxygen on the left and 6 on the right. It should be exactly the same number. Okay, so that is not properly balanced. Mixtures and chromatography. Description of air. Is air an element, a compound, or a mixture? It is a mixture because it is made of different substances not chemically bonded together. It's a mixture of elements such as nitrogen and oxygen and compound such as carbon dioxide. Argon can be separated out from air Will the chemical properties of argon as a separate gas be different from the properties of argon in air? Explain your answer. No, the chemical properties of an element are not affected by being in a mixture. If you remember when you were little, you may have seen this experiment when you react sulfur and iron to make iron sulfide. When it's in a mixture, iron is still magnetic and you can extract it with a magnet. But when your reaction takes place to make iron sulfide, your substance is not magnetic anymore. Okay, so you can change the property in a compound, but not in a mixture. A simple chromatography experiment was set up, and we have to outline the procedure. So quickly, you're gonna take your chromatography paper. You're gonna draw a line with a pencil near the bottom of the chromatography paper. You're going to put a small sample of inks on the line. Pour a shallow layer of solvent in a beaker or the container. Place the chromatography paper in the container. The line must be higher than the solvent. Okay. You're going to place the lid on the container to prevent the solvent from escaping, and you're going to let the solvent rise. When the solvent gets close to the top of the chromatography paper, remove from the container, and then you can analyze the results. It's really important to use pencil for the line, not a pen, because otherwise the ink would smudge and that would ruin your result. If you look at the data here, A is made of one dye, B is made of two different dyes, and C is made of three different dyes because you have three spots for C. And B and C have one dye in common because the first dots for each substance is at the same height. A student was given a mixture of insoluble chalk powder and solid potassium chloride. One of them is soluble in water. Outline a method for separating the chalk from potassium chloride. So you're going to pour both your mixture in water. Only potassium chloride will dissolve. The chalk powder will stay a solid. Then you can filter it out. So the chalk will stay on the filter paper and the dissolved potassium chloride will pass through. How could I get pure crystals of potassium chloride from the solution? Then they would evaporate the water from the potassium chloride solution. The method is called crystallization. Time for the code. Send me an email. Tell me what is the best book you've ever read. Can be anything. Can be comics, can be manga, can be a proper book. It's up to you. I have a really hard time finding mine, so I won't give you my answer, but there are a few. Next, powdered iron and powdered sulfur were mixed together. Information of the solubility of iron and sulfur is given in Table 1. Use the information to explain how the iron and sulfur could be separated out again to form pure iron and crystals sulfur. So we notice that both of them are insoluble in water. So if you put your mixture in water, none of them are going to dissolve, so you can't really use that to separate them. But iron is insoluble in methylbenzene, but sulfur is soluble. So if you pour your mixture in methylbenzene, only the sulfur will dissolve, which means that you can then filter it out. Okay, the iron will be left on the filter paper, and the dissolved sulfur will get in solution. Then you can evaporate the solvent, the methylbenzene, to obtain pure sulfur. And then some of the mixture was heated in a fume cupboard. Iron 2 sulfide formed. A student stated that the iron and sulfur could be separated back out using physical processes. Is the student correct? Explain your answer. He is incorrect because you cannot separate the element of a compound using physical processes. They are too strongly attached. You will have to use chemical reaction. Oh. Here we go. Incorrect. Iron sulfide is a compound, so iron and sulfur are chemically bonded. Only way to separate them again is through a chemical reaction or to use chemical processes. And this is it for today. Hope you enjoyed this. Make sure you bring your homework back in class on the right day. Make sure you have all the correct answer. Make sure you're revising really hard. Stay amazing. Talk to you very soon. Bye-bye.